Hi everyone, I'm 𝐀𝐧𝐝𝐫𝐞𝐰 and welcome to this exciting workshop at Testmu 24. In this workshop, we are diving into something that has been giving a lot of traction in the testing community, Playwright. If you have been curious about how to take your Playwright test to the next level, you are in the right place. This workshop is all about taking your Playwright test to the next level. We will be covering advanced topics like using page objects, custom fixtures, and proper data management. Plus, we will be even giving into distributed execution using Lambda test. So your test can run across different configurations without an issue. Our workshop leader, Andrew Knight, who you might also know as Automation Panda, is a true expert in this field. He is the Senior Director of Product Management at Cycle Labs, where he focuses on test automation excellence. He is also a Playwright ambassador, and he has been an incredible background in open source development, including his work on .NET screenplay pattern. Andrew's passion for software quality is evident in everything he does, and he is here today to help you become a pro at Playwright automation. Feel free to ask your questions in the Q&A tab as we go along, and Andrew will address them at the end of the session. Andrew, we are excited to learn from you. Hi, how are you?
I'm doing great. How are you, Sparsh?
I'm doing great. Awesome.
Awesome.
We are very much excited to learn Playwright and like how to advance ourselves in Playwright. So over to you.
Awesome. Thank you so much. And hello, everyone. Thank you for taking time out of your Friday to join me to learn about testing and specifically Playwright. As Sparsh said, my name is Andy Knight, also known as Pandy. I am the automation panda. I build solutions to testing problems. Hey, I see you there, Kailash. Good to see you in the chat. Today we're going to spend 90 minutes learning how to robustly scale our Playwright tests. The way this is going to work, I'm going to give a bit of introduction with some slides to kind of talk about what Playwright is, what it isn't, how it compares to other tools. Then we're going to jump into code. And I'm going to give you the example code. I'm going to be live coding on the screen. It might be a little bit easier for you to just kind of follow along watching it like a video rather than try to like code along in real time. Just the nature of a virtual session, it's kind of tough. But all the example code is in GitHub, so you can get it afterwards. You can try it out. You can ask me questions and all that kind of stuff. Another thing is that when I do these kinds of live workshops, things tend to be less formal, right? When you have like a 20-minute time slot, you've got to go through the talks. You've got to be very sharp, polished, to the point. Today is going to be more relaxed, more informal, more off the cuff. You might even see me make a few mistakes. So please bear with me on that. Anytime you have questions, please pop them in the Q&A at different times throughout the workshop today. I'll try to peek in there, see if there's anything I can quickly answer. And then at the end, we'll also reserve about 15 minutes to flush out all the final questions. So this is meant to be active. Like I said, if you got questions, don't be shy. And let's jump to it. Bam. All right. So first question is one I have for you. How many of you have used Playwright before? Well, I guess you can't raise your hand. This isn't live, but like put it in the chat. Like, let me know. Are you new to Playwright? Have you been doing it for a couple years? Do you consider yourself beginner, intermediate, advanced? That kind of gives me a bit of a perspective on how deep to go on certain topics. So somebody using Cypress, oh my gosh, new to Playwright, beginner, new, okay, cool, intermediate. All right, very good. Very good. So it looks like a lot of folks are new, which is totally fine. At one point in time, I was new to Playwright too. It wasn't that long ago. Playwright's not been around that long. Just Garson used it a bit, moving from Selenium like a champion. Ain't nothing wrong with Selenium. It's just different, right? All right, so let's learn about what Playwright is all about here. So, what is that? That's weird. Okay. Looks like, no, it's fine. Okay. So getting started off, like I said, I'm going to be jumping into example code later. So here is the GitHub repository for that example code. It's at github.com/automationpanda. That's my account /awesome web testing playwright. You can also scan this QR code now to get access to it quickly. I would say go ahead, visit the website if you want to, clone the repo, and then you'll have the code for reference as we're going through later. And then after our session, you could even dig in and take the full instructions of it. Okay. So even if many of us are new to Playwright, I'm sure many of us are not new to testing and automation, right? We've been around the block. We've probably written who knows how many test cases, automated who knows what with Selenium and Cypress and all these other tools. And I have too. I mean, I've been in this field, this area for a decade and a half at least. Right? I feel old. I'm not that old, but I am old. And in all of my time working on testing and automation, I feel like I keep hitting the same problems over and over again, regardless of what tool, what framework, what language, what the product, whatever I'm testing. I found that overall, like tests feel very slow, right? Except for unit tests. I'm talking like end-to-end tests, feature level tests. Tests can be very slow because you got to get the thing up and running. You've got to send the interactions to it. You got to wait. You got to do your timing. So tests take a long time to run. Tests also tend to be very brittle, right? If you change anything in the application under test, kaboom, your test itself just explodes, right? That sucks. And then tests are also flaky, right? How many times have you had like element not found error? Raise your hand. Yes. Shared trauma. This could be a therapy session, right? How many times have you had a timeout and you're like, why? But the thing was there, right? Flaky tests have been the bane of end-to-end testing for forever, right? Other pain points, to be real here, sometimes you get assigned a test and it just doesn't make any sense. You get a test procedure and it's like 100 steps long and you're like, what in the world is this thing trying to do? Confusing. And I read it, and a lot of times it's like the first 90 steps are just set up. they're copy pasted from all the other tests in that repository. You're like, what? This is dumb, right? Another fun aspect for those of us who have worked on uh, test teams, like QA teams, from a business standpoint, the tests don't make money, right? The tests aren't building new features, right? Testing is a cost center, and a lot of times that means that testing work is shortchanged, or even to the case where test engineers are treated as second-class citizens, which can really suck. No bueno. And then also, this last one particularly hits developers hard, is that changing into testing work requires changing mental context. So if you're a developer and you're coding along and then you have to switch into testing mode, that can be very disruptive to your flow state. So these are all big challenges that we have seen and lived with testing. To try to mitigate these issues, what we collectively as a testing community have done over the past, I mean, this for the past like 2 decades now, we tried to follow this model of what we call a testing pyramid, right? When you say pyramid, oh my gosh, I'm not talking about Egypt. You know exactly what I'm talking about. I'm talking about the the numbers of different tests and the amount of testing effort we should put at different levels, right? And the pyramid for generally looks like this. We say that there are we want a strong base of unit tests at the bottom, right? We like lots of unit tests. Why? Unit tests are short, sweet, to the point, very stable. They're as close to the code as you could possibly get. And so if you have a strong base of unit tests to start with, then most likely you're already achieving high quality, and other higher level things are going to go better, right? So we like lots and lots of unit tests. Then as we go up the pyramid, we go look at things like component tests, right? Component tests for UI components. Let's say you're doing, a web app or something, or mobile app. The idea that, hey, component testing is like UI unit testing. And so, that's still unit testing. That's really good, very stable, right? We want to have lots of those too. Move up the pyramid, then we hit integration testing, or API testing or database testing, right? The integration points, a lot of times it's just APIs, right? That's what we think of. And APIs are still mostly good for testing because they're still pretty fast. They're fairly programmatic, request, receive, ratify, that pattern. But they have a problem because you have to make a network call and then you have to get a response back. So they're going to be slower, right? Whereas a unit test might take 1 millisecond, an API test might take 1 second round trip. And then if anything goes wrong with the network or the authentication, there can be some flakiness there. So that's like, they're a little sus, but they're okay. And then finally at the top, UI tests, the big old end-to-end tests, right? These are bad. These tests are very, very bad. Why? Because they're complicated to write. They're very slow to run. They're the most flaky, right? And so we put them at the top of the pyramid to say we want to have the fewest of those, limited to happy paths. And so that's kind of how we get our pyramid structure. The more complicated the test, the longer it runs, the flakier it is. We want fewer of those, and so they go to the top of the pyramid. My problem with this is that this framing of the pyramid labels certain kinds of tests as good and bad, when in reality, I don't think that tests should be labeled as good tests or bad tests by their nature of what they are. All different kinds of tests are good. Tests at all levels are good and important for mitigating risk. We shouldn't be labeling UI tests or end-to-end tests as bad simply because they take longer to run or because they're more complex to write. Arguably, UI tests, you could say they're the most valuable because they're actually testing the software like a user would, right? In most cases, where it's getting all the things together. So I don't really like how the pyramid has framed this test strategy the way it is, right? So really, rather than try to be stuck in this pyramidal framing that I think is misleading and wrong, I want us to think about more modern testing goals. And so here I have 3 goals that I've really been focused on for the past couple of years for myself. So first of all, I think we should be focusing on building fast feedback loops rather than building a quota of certain kinds of tests, right? Ultimately, nobody cares what tests you write. People care about the feedback that you're being given as part of your development and quality process, right? I want to know when something breaks. I want to know when there are issues. And whatever tests and systems it takes to get me there, yes, just like Amanda's saying, people don't care about what you're testing, they care about the results, right? The whole activity of testing is providing fast feedback in the quality feedback loop. And so I think we need to focus less on making sure we have certain types of tests regimented and more on getting the fast feedback loops on the information that is most pertinent, right? So that involves things like, continuous testing, CI/CD platform, making sure you're integrating your tests into pipelines, keeping your tests as efficient as possible, making sure you're covering the most important behaviors, not just 100% automation kind of stuff. Second modern testing goal is we need to make our test development as fast and painless as possible, right? We're never going to shake the perception that testing is a call center. Like we can justify it and we can point to the value it adds and yada yada, all this stuff, right? But ultimately, there's always going to be that perception that testing is just extra time taking for risk mitigation, right? And so the more that we can optimize that process, if we can get the same amount of feedback in less time, the better off we're going to be, right? And so when we go to develop these automated tests and these automated systems for providing feedback, we need to make sure it is part and parcel of our development process, not something where somebody does development, throws it over the fence, and then somebody tests it, but it's really just all part of one workflow. And to do that, we want the ability to develop new tests not to be some arduous journey, but to be as fast and painless as possible, right? And then third, along with that, we need to choose test tools that naturally complement developer workflows, right? If you have to do a whole bunch of mental context switching just to write a simple test case, that means that testing is going to be inefficient, that it's not going to be fast, it's going to be rather painful, right? So we need to make sure that we're building tools and selecting tools that can naturally complement a more efficient workflow. And that's where I believe Playwright really comes in. I see Playwright as a truly modern software testing and automation tool that can work within our existing workflows, that can be fast, efficient, seamless, and can really help us focus less on getting hung up on the type of testing and more on getting fast feedback that is rich and valuable. So, what is Playwright? Playwright is an open source web test framework from Microsoft. It's from the same division of folks who brought you Visual Studio Code and TypeScript and all those other great developer tools. It's fairly new-ish, though I can't quite say it's new anymore. I first learned about it in like 2021. I think the project started in like 2020 or so. And in the past, I would say 2 years, it's really taken off in popularity. The way Playwright works is that it manipulates the browser under test via debug protocols, kind of like going in the back door, like Chrome CDP and that kind of thing. And because it's using debug protocols instead of other protocols, it actually runs really, really, really fast. It is the fastest of all the test automation tools. There are plenty of benchmarks out there that you can see just in terms of the test execution time. Playwright beats the pants off of everything. Now, something that makes Playwright special is that it doesn't necessarily work with the full browsers like Google Chrome or Mozilla Firefox, but rather it works primarily with browser projects, like the projects and the engines underneath all the big browsers that are open source. And so instead of testing Google Chrome, you'll be testing Chromium, which is the open source project under Google Chrome and Edge. It can also handle the Firefox browser projects as well as WebKit being the thing under Apple Safari. And so with those three browser projects, you're basically getting like 99% of the browser market. There is also a way that you can test the big browsers. You can test full Google Chrome. You can test full Microsoft Edge using browser channels. But the default out of the box are the three browser projects. So, like I said, Playwright is awesome. It's fast. It's more than just a browser execution engine. It does provide a full test framework, especially if you're using the JavaScript or TypeScript bindings. It has built-in automatic weighting. It has a test generation tool. It has a UI mode window that you can use to launch your test, and we'll look at that. And just a whole bunch of other really, really cool features. They tend to pop out a new release every month or two. I can't even keep up with it, and I'm one of the ambassadors, right? So you can also do API testing with Playwright too. And a lot of times, I mean, I've even had people, can I use Playwright just for API testing? You can, but I think where it's really valuable is when you can use UI and API together. And one of my favorite parts is that it provides bindings in all the different languages. So the native binding would be in JavaScript or TypeScript, same, it's recommended. But it also has bindings in Python, Java, and C#. If you know me, you know I'm a big Python guy. So the fact that there's a Playwright binding for Python is just chef's kiss. Awesome. Playwright also works a little different in how it sets up and tears down browsers. If you're familiar with Selenium WebDriver, you know the pattern where every single test, the best practice is you create a new browser session, which means you start a new WebDriver executable and it starts a whole new browser process, and then your machine gets tanked for a third of its RAM, right? When Google Chrome starts up. And then at the end of the test, you have to quit the browser so that you free up your system resources, and then the next test will open up a new one. And while that is safe, it is very time consuming, right? You're taking probably about a 10-second hit per test just to open and close your browser sometimes. It's probably a little bit more efficient now, probably only a couple seconds maybe, but you could expect, up to a 10-second hit per test, and then all the system resources being up and down. With Playwright though, when you start a test, there's actually only one browser process running across all of your tests. So when you start your test suite, there's one browser process that runs, and every single test is using it. You're like, well, wait a minute. How is that possible? Well, what Playwright does to keep system resources to a minimum, you have one browser process, but then every test pulls a browser context out of that singular browser process. And the browser context is kind of like an incognito session within the browser. So it has its own session, it has its own storage, it has its own cookies. So it's essentially like a private session or a private context that with that test, since that test is the only one that has that context, it's safe. Um, so you can actually have one browser process, but each test pulling out its own context. And contexts are much faster to spin up. I mean, it takes like a split second to create a new context or to destroy a context. And you can have multiple contexts, meaning multiple tests happening in parallel on the same browser process with almost no performance hit. So it's really, really cool. And so that way you can spin up, or you can start and tear down tests much, much faster with Playwright. And so not only is the execution of all of your interactions much faster, but the setup and tear down is a whole lot faster too. Now I know I've been making a lot of comparisons to other tools like Selenium and Cypress, and there's others like WebDriver IO out there and all that kind of stuff. Um, Here is a chart that shows all the differences at a high level. So take a screenshot, check it out. I'm not going to go into too much detail here, but just to give high level comparisons. Selenium WebDriver is the classic tool. It's old school. It's still king. It still has the most downloads and market share and all that. But Selenium WebDriver is essentially just a browser automation engine. You need to build your framework around it. And so that's why historically Selenium's got a bad rap for flaky tests. It's not that Selenium as a tool itself is flaky, but it doesn't do anything to help you handle your waiting. It says here's the low level API, here's how you do it. Now you have to handle it. And so a lot of testers over the course of history have written rather flaky tests with Selenium because there was nothing in Selenium to stop you from doing that, right? Cypress came out a little bit later. I think it started in about 2016. I first learned about Cypress in 2018. Cypress was really the first web testing tool that focused on excellent user experience, and it became the darling test tool for front-end developers. And there are some QA teams also that jumped in on it. The problem with Cypress is it's very much trapped inside that browser. JavaScript only, same browser process. You can't even open a second tab, right? So there's limitations with Cypress. Playwright manipulates through debug protocol, so it's a lot faster. It has many of the languages that say Selenium supports, but with more of the nice developer experience that Cypress offers. And it's been growing in popularity. It's been growing in market share. You can see the number of GitHub stars, right? It's really exciting to see the journey the Playwright's gone on. So with that, that's going to end our slides. Let me pop over to the, let's see if we have any questions I can answer real quick before we jump into code. All right, so Mukesh answers, what strategies can be used to reduce test flakiness when automating web tests with Playwright? Great question. The fact that Playwright has automatic waiting built into all of its interactions means that your tests are going to be much, much less flaky. 90+% of flakiness in test automation comes from improperly handled race conditions, meaning you didn't wait for the thing before you try to interact with it. And it can be complex to try to handle waiting yourself if you've ever done that in Selenium, and a lot of times you miss it. But in Playwright, like when let's say you click a button, it waits for that button to be actionable before you click it every single time. And so that dramatically reduces the flakiness in your tests. And you also don't need to keep adding these hard sleeps all throughout. Like you don't need to say, wait 10 seconds here, wait 10 seconds there. No, you just have the automatic waiting built in. So great. How do I, oopsie. I don't see how I can mark that as answered. Oh, well, we did answer it. So let's move on to the next one. Let's see. Mahesh, how does Playwright address common testing challenges like flaky test maintenance? We just talked about the flaky test thing. I mean, test maintenance, you're still going to have to do that anytime your product changes. Your tests have to change, but the amount of code you have to write in Playwright is a bit less than say Selenium, because the API is rather concise. I would say Cypress has the most concise API, by the way, but yeah, okay, cool. So Advika, how do you approach testing dynamic or interactive web elements with Playwright in TypeScript? Let's hold on to that for the code. I'll come back for that one. Let me just do a quick perusal to see if there's any others that would be good. Here's one. Vijo, what are some advanced Playwright features in TypeScript that can improve test reliability and efficiency? So the reliability efficiency thing, that really comes down to the automatic waiting. With the TypeScript binding, you also get the Playwright test framework, which we will be using. That one, it provides a lot of extra richness on top of, say, like Jest. So we'll see a lot of that there. All right. So looks like a lot of these other questions are all focusing on code. So I'm going to pause on answering questions for now, and we'll jump into code, and then we can come back and answer some of them later. All right. So bam, bam. One moment here. Oh, we're good there. Okay, so let me come back here. So again, we have our GitHub repository that I'm going to be using. If you want to, pardon me, see where it is, here's the QR code for it again, real quick, friends. It's at github.com/automationpanda/awesome web testing Playwright. In fact, I should probably just do this. I can put that link in the chat. I don't know why I didn't think about that sooner. Okay, boom, boom, boom. Okay, so that's the example code. Let's actually jump into some live coding here. So let me pull up my terminal. Boom, 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 boom. There are multiple ways that you can set up a Playwright project. You can do it yourself. You can do it through VS Code. I typically, I'm old school. I do it through command line. So I'm opening up my command line here. I'm working on Mac OS, which is Unix based. The commands are pretty much going to be the same for Windows as well. But here we go. So where am I? I'm going to go into my code directory. CD. Let me get rid of the old one. All right. So I'm going to make a directory for a project here. We'll call it Testmu Playwright. Bam. Oh, come on. Playwright. Okay. Okay, so I'm in my directory. If I want to set up a Playwright project, what I can do, you're going to need to have Node.js installed for this. Let me show that here. So I'm running Node version 18. But if I want to create a new Playwright project, I can say npm init playwright at latest inside my directory. And so what this is going to do is it's going to walk me through setting up the project and configuring all the options. So here, is it okay to proceed? Yeah, let's do this. Boom. All right, so you can choose if you want to use TypeScript or JavaScript. I recommend TypeScript because TypeScript is JavaScript with types, and a type system is very, very helpful. That is my opinion. I'm sticking to it. I think all new projects should be done in TypeScript, not JavaScript. I will die on this hill. Don't fight me. All right. So now it's going to ask you, like, where do you want to configure things? Where do you want to put your end-to-end tests? I say take the default, the tests folder. That's, roughly, or that's what most people would expect inside this kind of project. Add a GitHub Actions workflow. You can, let's not do that for now. Install Playwright browsers. I would say yes. When it's saying the browsers, it's referring to those browser projects. It's going to install the latest project versions of Chromium, Firefox, and WebKit for you on your machine. So that way you don't have to manage that on your own. Playwright takes care of that for you. I will warn you, it will take a while to download if you don't have a fast internet connection. I'm on Google Gigabit Fiber, so I'm not going to worry about that. I will just do it. Boom. All right. So now it's creating this. There it goes. So it's going to create the package.json file, and it's going to install all the dependencies. Here now I'm downloading the browsers, so you can see it's going pretty fast. Each browser project can be like about 100 megabytes or so. So be warned of that. Like if you're running in a CI system, you probably want to have a container image with the Playwright browser is already installed, so you don't have to wait a couple minutes every time you run your jobs. But here we're just setting it up. It'll go pretty fast on my machine here. So it's getting Chromium 128. It's getting Firefox 128, and it's going to get WebKit, whatever version of WebKit. So yeah, it looks like Chromium is 138 megabytes, Firefox is 80 megabytes, and WebKit is 68. That's cool. Downloading WebKit 18. Woo! So fast. Gigabit fiber internet is amazing. Okay. Happy hacking. Happy hacking. It should say happy testing. That's fine. It's fine. I won't get annoyed. Okay, so now that we've got this open, you'll see that we've got files in our project. Yay. Fun, fun, fun. So at this point, I'm going to open it up in Visual Studio Code so that we can see it rather than just on a terminal. Code, scratch. Come on, mouse. Testmu Playwright. Open. All right, and I will, yes, I trust the authors. I am the author. I wrote the playwrights. We increase font size here so we can see a little bit clearer. And I also have the Playwright extension for VS Code installed. Very nice. Highly recommended if you're doing it. You can use any editor you want. I mean, if you like something else, great. I think VS Code is fine, right? You can get any extension in the world. It gets the job done. So inside of here, you can see we have our packages.json file with all of our dependencies for Playwright. Yay! We have a Playwright config file that configures how Playwright stuff is set up. Don't worry about that right now. And then it also gave us some example tests, right? So I have under the tests directory, there's example spec.ts that has some very, very concise, short Playwright tests. And there's also the demo to do app spec, which is a much more comprehensive set of test cases. One thing, I don't know why they do that. They have a test folder and a test example folder. I'm going to move demo to do app test to the tests folder. You'll see why in a moment. I'm going to get rid of test example. Delete that. We don't want that. Go away. Okay. So now we could walk through this code and look at it together and blah, 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 learn, dense, wall of text, so difficult. What is even happening? I don't know. Or we could do it the easy way. Who wants to do it the easy way? Anyone? Nobody? I see hearts, thumbs up. Yeah, there we go. Let's do it the easy way. So to do it the easy way, we're going to run Playwright in UI mode. So I open up my terminal here at the bottom. To run Playwright test, you say npx playwright test. What we're going to run in UI mode, you add -- UI, and then magic happens. Does magic happen? Where's the magic? Oh, it came up on the other screen. That's why. Okay, let me see if I can increase the size here a little bit as well. All right, so this is Playwright's UI mode. Isn't it fancy? Look at how fancy this is. So if we're looking here, on the left sidebar, you will see all of the tests in the project. And so we can see we have demo to do app spec TS. That was the complicated one. We have the basic example one. And what I can do is I can run these tests. So if I just want to run the example tests, I can run them here. And they're running. And look how fast they were, right? 1.4 second, 1.5 second. I can even run all the tests. Let's just run them all, right? It goes pretty fast. And so right now it is running them against Chromium, right? I could change the browsers that it runs against, but this is fine. And I can see I have all 26 of my tests passed. And if I select them, I can go down in here and be like, hey, boom. And if I click one of the individual test specs, then you'll see the main view updates. We can see that here on the next pane, we have a list of all of the web interactions that performed using Playwright, including before and after hooks. So that was like setting up the fixtures and stuff. And it's like, hey, you have locator check, expect to have class, page wait for function. And as you notice, as I'm hovering over each of these steps, it is showing the visual snapshot of what's going on at that moment of time in the test. And it's almost like it's playing a video, right? As it goes through each and every step. It's amazing. I could even come up here to the top to the timeline, and I can see in real time exactly as everything was happening. So, for the first second, nothing was happening. Then it loaded. Then I started doing some interactions. I said, buy cheese, feed the cat, book a doctor's appointment, right? I could even come in here and start to do some element location on different elements in this particular page. If you look down here, like if I click this buy some cheese, at the bottom it's saying locator. Hey, it's giving you a locator you can use for calling that particular element. And moreover, also as I hover over these steps and I click on these steps, you can see that the UI window will show you exactly where in your Playwright code that step happened. So if you're like, oh, something went wrong, where in the code did that happen? You can very easily get to it. It's pretty awesome, right? You can rerun your tests anytime. You can run them against different browsers. You can filter. I mean, there's stuff in this UI mode that I'm not even fully aware of, right? Wow, I know it's pretty incredible. The whole point here, like I said before, is developer experience, right? You are developing your website and you're developing the tests to test all those behaviors in your web app. And so to have this really nice environment for running your tests and then seeing what they did and then trying to figure out where things went wrong, super duper valuable, right? So that's UI mode. And you can see like just all the tests are right there. So here we are. We have created a Playwright project. We have run Playwright tests, and we haven't even really written any Playwright code, have we? Right? Like, oh my gosh, everything has been out of the box for us so far. That's pretty cool. So, I mean, if we wanted to look at some of the Playwright code, like here's this example spec. These are the small tests. If we just do a quick walkthrough of what's going on in this code. The top, we have an import. We're importing a function called test and a function called expect from Playwright library. Then here we have two different test definitions, right? First of all, we have test that some page has a title. This is very similar to Mocha or Jest, if you're familiar with those JavaScript test frameworks. Playwright test is its own test framework. I believe it's built on Jest. So it has a test function. You give it a name, has title. Then there's the async callback for the procedure of that test. We are declaring that this test is going to use a fixture called page. In Playwright, you do everything on the page. The way that this is given to you, if you recall from before, the way Playwright sets up browsers, it sets up one browser for all the tests. Then it creates a browser context per test. And then within the browser context, Playwright will create an initial page object. And that is the page that is given to us here. And so from the page, we can do everything. We can click, we can check if things are there, we can wait for things. And so here we can see that right away. The first thing we're doing in this particular test case, we're saying await page.goto some URL. This is like the navigation interaction. Page is the page object. That's the thing. It's kind of like if you're familiar with Selenium WebDriver, when you say driver.do this, driver.that, driver.find element, driver.load, right? Or in Cypress, cy.this, cy.that. In Playwright, it's page.this, page.that. And so here we're saying page.goto. Goto is a method to load a particular URL in the browser, and we're giving it that address. All interactions in Playwright and TypeScript are asynchronous. So that means we need the async await keywords everywhere. If you are familiar with JavaScript or TypeScript, you're probably familiar with asynchronous programming and promises. And that's great. That's awesome. You can do some really cool tricked out stuff. If asynchronous programming seems new to you, you're like, what the heck is all this? Why do I have to put this await command everywhere? Don't worry about it. To be successful with Playwright, you don't need to know asynchronous programming. You just need to put await on everything. Yes, I know it's annoying. Sorry. Just any interaction you're going to need to await because it's making a promise to be async. So hence await page.goto. Then what we have is we have another call. And this, whereas this was an interaction, this is a verification. Hence it's using the expect function. Remember, testing is interaction plus verification. So what does this verification look like? We're saying, okay, await, expect your page to have a title of Playwright. This reads very much like plain language, which is really cool. So let's unpack this. Anytime you want to perform assertions, you're going to use the expect function. And you can do expect on different things. You can expect things to be true of the page. You can expect certain things to be true of elements on the page. And so for this test, we're expecting something to be true of the page. So we say expect parenthesis page, whoops, close parenthesis. And then once we have this, then we can use any of Playwright's web first assertions. So when we check to have title, what Playwright is going to do, it's not just going to get the value of the title screen and do an equal on it to see if it matches. It's going to actively wait until the page has the matching title. So, sometimes it might take a split second for the page title to change. That way, with Playwright actively waiting until the thing becomes true, you're handling those race conditions. You're handling that waiting. You're less likely to flake out and crash the test. And you don't need to do any special logic for that. Playwright has it built in for you. So you can write your tests like they are mostly in plain language. Expect your page to have this title. Oh, wow. Similar things are going on in the second test here. So again, testing interaction plus verification. We have our test declaration function. We have the name of the test. We have the callback using the page. So we go to playwright.dev. Then what's the next interaction? The next interaction is interacting with an element on the page. So here, click the get started link. We're saying await page.getByRole link getNameStarted.click. Okay, a lot going on here. So start with the page, and then we see page get by role with some stuff. This is one of Playwright's locators. Now, many of you, if you've done Selenium before, Playwright or Cypress, you're probably fairly familiar with web locators. They're the things that point to an element on a page. And there's many different kinds of locators. You can have IDs, you can have CSS selectors, class names, XPaths, right? All this kinds of stuff. Playwright has a set of custom locators, and this get by role is one of them. So here we're saying, hey, I want to get an element by its role being a link, right? Other roles could be things like button or label or other kinds of things. And the name of that link is get started. these kinds of locators are arguably more readable. You could argue maybe they're a little more robust because they're looking at aspects of the element versus any sort of like cheat code or something. Um, and so, yeah, if we hover over here, we can even see the documentation of that. Get by role. Here are all the different kinds of roles you can have. So they're naming things like what you would see on different elements, like an alert, an image, a link, right? And then there's extra options for like things like the name and all. So anyway, we find our elements, and once we have our elements, then we perform an interaction on it. So I want to find this link and I want to click it, right? So with that, again, Playwright has automatic waiting built into this. So it's going to wait for the element given by this locator to be actionable. Once it is actionable, then it will send the click interaction to it. So that way you're avoiding all those race conditions and stuff. Okay, so then once you click that link, what are we expecting to happen here? So we have an assertion expecting the page to have a heading with the name in there. So here now we're saying, okay, expect page dot. Now we have another locator, get by another role. So we're saying, what is this element we're looking for? Well, it has a heading and it's named installation. So I want to get the element that's a heading with the name installation. And I'm going to expect that heading, notice the open close parentheses here. I'm going to expect that heading is visible on the page, meaning it's being displayed. So very, very basic kind of web test, but very common flow that we would see. You go to a page, you do some interaction on the page, you make sure something appeared because of it. And so what's different about this assertion this time is instead of being an assertion on the page, it is being an assertion on a particular element on the page. Hence, you have a locator being put into the expect function rather than just the page itself. And then we perform an assertion, again, a web first assertion performing all that waiting on that particular element. If I wanted to, we could look at what all the different other assertions are with, control space, autocomplete. You can see, you expect that element to be attached, to be checked, to be defined, to be disabled, to be edited, to be empty, to be enabled, to be falsy, and the list goes on and on and on. This is one thing I really like about Playwright, and specifically using Playwright with TypeScript, is that I feel like the syntax just flows with me, right? It's very logical to say, hey, you start with your page, you get an element on the page, you do something with that element, right? And to be able to kind of say dot control space and then to see all the different kinds of interactions you can perform. You can have all the different kinds of assertions you can perform. Eric Terry, that's right. Use the force, right? Use the autocomplete force. Indeed. I mean, real talk here. Do you think I have memorized every single Playwright method? Hell no. I can barely remember what I had for breakfast in the morning, right? So the fact that I've got autocomplete with typing, really helps me figure out the right code to write, because it's like I can't remember exactly what a method name might be, but I know it's like I need to make sure that the values are equal. So what is it? Oh, it's probably like to be, or to have values or to have text. Ah, perfect. Yeah. So that's really, really nice about Playwright. Okay, let me take a quick swig. And let's look at the questions here. See if there's any others we can answer. All right, so I'm going to come over here to question and answer. I see Advika has asked, how do you approach testing dynamic or interactive web elements with Playwright and TypeScript? So here we can see the code in TypeScript. When we're trying to interact with elements, we're doing that page dot locator dot interaction or dot assertion kind of formulation. And so when we have like dynamic or interactive elements on the page, sometimes like elements may or may not be there. They may appear only after triggering certain interactions. And so like you're going to need to sequence your test and write your locators to identify the right things. But you can also have a little bit of assurance with the automatic weighting that, you know, Playwright's not going to die if it doesn't find it right away. You know, for example, like in here, you know, we went to a page, then we clicked a link, and then we were to check an element after clicking that link, because after clicking the link, it's probably going to go to another page, and so that page is going to have to load. So there's a little bit of delay time, right? I didn't need to explicitly put any weighting here. You know, that was dynamically done, and so this was going to be safe. All right, great question. Let's see if we can. All right, so Mr. Reyna, how do you set up a Playwright project with TypeScript from scratch? Well, we just walked through that, right? You can do it from the command line with that command npm. What was it? The command was npm init playwright at latest. If you go to playwright.dev and go to the getting started page, you'll find that command there as well. I think you can also create a Playwright project through VS Code. And also the init command will work in an existing project as well. So if you already have, let's say, a JavaScript front-end project and you want to add Playwright to it, just run that command inside that directory and it will add it. It won't blast anything away. All right. So those two questions have been answered. What are the best practices for structuring and organizing tests in a Playwright project? So I would recommend that in any project you do, whether it's a project dedicated for tests or if it's like a front end project that you're adding Playwright tests to, put your tests in a directory called tests from within the root directory. That is the best place to put it because that's what people expect to look for in a JavaScript-y kind of project. If you're using Playwright in different languages, you're going to be using different frameworks. For example, if you're in Python, you're probably using Playwright with PyTest. And so the PyTest convention is also a directory named tests. If you're doing Playwright in Java, you're probably using JUnits or TestNG, maybe even Cucumber. And you're probably using a directory layout like Maven. And so you would be putting it in the Maven directory layout under, what is it, source. It's like source tests Java or some I forget off the top of my head, right? You know, so put it conventionally where it goes there. Within, let's say here, within this test directory, you might want to have some subfolders for different things. And in fact, what we're going to do next is we're going to write some more advanced tests and show how all of that works. We can put them there. So yeah, but ultimately, use your common sense. Okay, what other questions can we answer right now? Are there any other good ones? Okay, so getting to the locator strategies. Here's one from Mike. Why is get by text, placeholder, etc. the best locator strategy for a stable tester nowadays? A few years ago, it was IDs and classes, but now they are considered to be a bad practice. Tests can easily change as well, especially when you work with the CMS. Yes. Excellent question. So I agree with you, Mike. I don't fully agree with the assertion that these get by text, get by placeholder, get by role locators are better than other more traditional locators. I think they're different. I think there are advantages and disadvantages. The way that I look at writing locators is I want to write the simplest, most direct locator to find my target element as I can. And so typically what I look for first and foremost are IDs and test IDs. Why? Because you can't mess them up. There's no misfire. You either got it or you don't. They're the most efficient thing to find. They're the easiest thing to write. And they help you mentally, whether you're a developer or a tester, pinpoint this element has this given name. It has this identifier. We are calling it this thing. And so boom, I know what I'm getting. If I can't get the ID or a test ID or something, that's when I'll start to look at some of these others. And so there's a place for text locators because sometimes it's just easier to say, like, click the save button. Well, let me find a button named save. Well, there's only going to be one on the page. So let me just get that one. So that's easy and that's very, very readable, right? So I like them for that. But the thing is, like, any sort of text-based locator, what happens if you internationalize the app? What happens if you're in the locale for like Canadian French or something? Like, ew, now all of your English is broken. That's not so good, right? So, yep, yeah. So, pros and cons. What I recommend for locators is use, like I said, use the simplest, most direct locator you can, right? Try to focus on IDs. If you don't have them, maybe use some text or placeholder or CSS selector. Worst case scenario, fall back on XPath. Sometimes you don't have a choice, especially if you're doing like indexing or something. But try to avoid it if you can, but use it if you must. If you want to learn more about locators, I recommend go to Test Automation University. I have a whole course that I've developed up there called Web Element Locator Strategies. And I recently refreshed it last year to include things about like Cypress and Playwright. So that's my take on locators. Quick question from Paul here. Is Playwright with TypeScript capable of testing on legacy browsers code? Define legacy browsers and code. Or if you mean Internet Explorer, no. Nobody should be doing that anymore. Playwright can test, like I said, the browser projects, Chromium, Firefox, and WebKit. And then it can also test the full versions installed on your machine of Microsoft Edge and Google Chrome because they are Chromium based. Can't do Safari, sorry. Can't do full Mozilla Firefox, sorry. All right. So I'll stop the questions there for now, and we can move on to more learnings. All right. So what we've seen so far is just kind of like the little toy Playwright project it gives you out of the box. And that's cute and that's nice, but that doesn't really help you test scale. Let's take a look at a more intense example. And this is going to come from the repository that I shared before. Let me increase the size of, whoa, come on. Let me increase the size of this here so we can see our text. So I also need another project. Give me just a moment to set up here. A new window, file, open, code, automation panda, Trello View V. Okay. All right. So I have another project here that is from a friend of mine, Philip Hritz. If you know him, he's a very famous Cypress ambassador. And he has developed a basic little demo app that's kind of like a Trello Kanban board knockoff. So you can get the access to that repository and the link in the repository I shared. But for now, just follow along. npm start. I'm going to run this app just to show you kind of what it looks like. Here we go. So we have this little Trello app. Yay, fun. And what I can do is I can create a board, call it something like chores. And on here, I can create lists of things, like to do, in progress, done, right? And then I can start adding lists to this, like, hey, I need to walk the dog. I need to buy groceries. I need to mow the lawn. I mean, this looks like my weekend right here. Right? And you can click on this and you can see things. You can change things. You can go home and you can see now you have a list of board, right? So very, very basic kind of application. If we were to write some tests for this, we could. Yeah, this is the project I want. Oh, no. Let me do a quick thing here. I have to blast away the database to reset it. so it's fresh. So what I could do now that I'm back in my code, git branch. All right, so I'm going to git checkout. I'm going to check out the branch here. Those tests. Okay. So I'm in the branch for what would be chapter 3 in that repository I showed you. And here what I've done is I have created a new test in my tests folder called Trello spec TS. And here what I've done is I've written tests for this Trello app, or rather I should say a test for this Trello app. What we can see is this is a little more intense than the examples we've seen. I'm still importing my test function and my expect function from Playwright. Before all of the tests, what I need to do is I need to reset the database, right? Because I need my tests to start from a fresh state. I want the web app essentially to be empty. And I can do that with this very simple post endpoint calling to my local app running on port 3000/API/reset. In a real app, you probably wouldn't want to do this. This is just for testing purposes. So here I have created a test case. Test, create a new board with a list and cards, which is pretty much the scenario that I just walked through showing you in the app. And I'm using all the different Playwright commands that we've seen. So loading the app, page.goto. Creating a new board, await page, get by placeholder. What's the name of your first board? I put in chores, and then I press the enter key. Then I perform some assertions, expecting, and here's some other kinds of locators, right? Expecting page locator for CSS selector name equals board title to have a value of chores, right? Expect, there to be this button enter list title to be visible, and there shouldn't be any lists yet visible. If you ever need to invert an assertion, look at this. Expect something not to be visible. So all of these you can invert with not. Pretty freaking sweet. Okay. Now, after I create a new board on that page, I can create a new list, enter the list title, expect things to be true about that. So I'm creating a list called to do. Then I can add cards on that list, and you can see da-dun, 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 right? Add another card, click, enter name, placeholder, enter name for a card, fill, get by role button, clicked, fill in more, fill in more. Something really cool though, here we have a list of cards. You can do assertions on lists as well. So check this out. Expect my page locator for my card text, meaning the locator for all the different card items, to have text. And instead of putting in a string, I can put in a list of strings. And it's going to grab the text of each of those elements in the list it finds and go boom, boom, boom. This is hot. This is awesome. This is one of the reasons I love Playwright. When I say the API works for you, this is what I mean. Because otherwise, what would you have to do? You'd have to get a list of all the elements and then write a for loop over it and get the text of each one and match it up every single time. And if you were to do that, first of all, that's a lot of code. And second of all, it's not safe for waiting, right? Because you would do it once. Whenever you would access or whenever you would get the element and pull the text out of it, that text is now frozen in time. It's not actively checking to wait for the thing to meet that state. It's like, man, pretty lame. So, but this is just beautiful. All right, and then finally, I have a step to navigate to the home page where we're hitting that home button and we're going to see all the boards that I've created. So if I were to run this, I could npx playwright test. I'm going to run it from the command line here at the bottom. Now I'm going to give it options, project Chromium. I only want it to run on Chromium. By default, it'll run against all of the browsers in parallel. I don't want to do that because that'll mess up my database right now. But then I'm also going to give the path. So I can say tests/Trello spec.ts. We can run this. And, oh, did I project's name wrong? Oopsie, did I do a typo? I said chromium. What's the deal? CHROM. Oh, that's why. I put these out of order. It didn't like that. Ha ha ha. Okay, so let me put it here. Playwright test, tests/Trello. That looks better. Okay. I make mistakes too. I warned you about this. All right, so here we can see one test passed. Yay, that's good. And we can even open up the HTML report if we want and show this. Because we're not using UI mode. Now it's going to open up in a browser window, and you can see my test ran. And you can see all the steps of my test running, and I could even expand down, and you can see the code where it happened. So that's pretty sweet. So that's a more intense kind of test. Whoa. Control C. Now, you're probably thinking to yourself, this is probably not like the best test case because it's covering a lot of behaviors in one test. What would be ideal would be to split this out. Also, what would be ideal would be to maybe use some page objects instead of raw calls. So let's take a look at the code when we start to make this test better. So get branch. Where are my branches? So let's do the page objects first. Get checkout. Boom. All right. So now in this branch, the code in my test case is a bit slimmer. We're gonna do page objects first, then we'll split out the different behaviors. So we still have our for all here. We still have the same test case name. But now, instead of having a fixture called for the page, the Playwright page, we now have these three new pages. We have a get started page, a board page, and a my boards page. Each of these are page objects that I have created, and I have created fixtures for them as well so I can pass them in. And if we read our test case, now it looks like this. Load the app, await get started page.load. Create a new board, await get started page.create first board. The board's name is chores. And then await that the board page can expect the new board to be loaded with chores. This is much more readable, right? We don't see locators flying around. We see specific pages by name. We see specific interactions to perform all the pages. And it keeps going on. Board page, add list, expect board page list names to have a value. Board page, add cards, expect board page cards text to have these things. Board page, go home. My board page, expect load chores, right? So page objects right off the bat are making our test more readable. Let's take a look at one of these page objects. If we go under tests, I have a new folder called pages. And in here, I have my three page objects. So we look at the get started page. This is what a page object looks like in Playwright. I'm importing some of the types from Playwright. I'm creating a class in TypeScript get started page. It has a reference to the Playwright page, and it has a locator called first board input. In my constructor, I pass in the Playwright page, and then I also construct the locator for first board input. Page get by placeholder, boom, boom. This is a locator object. And then I have those two methods that you saw before. To load the page, what do? I say this.page go to the address, right? How do I create the first board? This.locator first board input, fill in the name, and then the same thing, press enter, right? That's how page objects are. A little bit more code, but it makes things a lot more readable and a lot more reusable. If we look at some of the other ones, like the My Boards page, similar kind of thing. I have a locator for my title. Here I have a method for performing assertions, expected that these are loaded. The board page is a bit bigger because there's more going on there. So we have a lot of locators, right? But the methods are all fairly straightforward. Adding something to my list, boom. Adding cards to the list, boom. Going home, expecting something to be visible, right there. All of that. Now, how I got the fixtures to work. I've created a folder called fixtures, and in here I've called Trello test. Here I'm importing all of my page objects. I'm creating a fixtures type that includes each of those page objects. And then I'm extending my base test to have fixtures for each of my objects. So that's how I can call these as fixtures here and just use them. Pretty nice way to set up the testing. I know it might be a little bit mind warping if you're new to Playwright, but just give the code a look when you get a chance. And now when I run the test, let's run the test again, and it should still be passing. Boom, look at that. Okay. So we've now made it better with page objects. Let's start to split apart these behaviors into multiple tests. So I'm going to come into this branch here to show it. Check out, boom. All right. So we have mostly the same code. You know, we still have the same page objects and the same fixtures, but in here now, in our Trello spec test, this is going to look different. So here now I have, instead of a test function to declare my test, I now have this thing called test describe. And again, this mirrors Jest and Mocha from JavaScript. There's this describe it should pattern that they use. Kind of weird. But basically, describe is like a block of tests. And so here I'm going to test describe my Trello-like board. And in here, you can see I have multiple test definitions instead of just one giant test altogether. So I have a before each method. This one's a little more complicated now because what I'm going to do is I'm not going to just wipe out the entire database, because now that I have multiple tests, if I wipe out the entire database, if they run in parallel, there's going to be data collisions, and that's bad. So instead of blowing away the whole database, I am going to have every single test create a unique board for it to use by itself. Right? Now, what's going to happen over time is the tests are going to add boards and boards and boards and boards and boards. So eventually we should probably do some cleanup. But at least this way, it's adding new data exclusively for each test to preserve test case independence and avoid collisions. So to do that, what I've done is I'm creating a random number for the board. I'm creating a name using that random number for the board. And then through the API, I am posting the creation of a new board for each test. So that way, this test will get board 1, 2, 3, 4, 5. The next test will get board 5, 6, 7, 8, 9, that kind of thing. And then I'm also directing the test to load the application in the browser and open the board of that particular name. So that way it's on the board as a starting point. From there, I can have a bunch of different tests safely run side by side. So I can have a test, should display the board name. Expect that board name to be displayed. Hey, should create the first list in a board. So here I'm exclusively testing the creation of a list. You should be able to create a list with multiple cards. So this test is creating a list and adding multiple cards to it. And then there's the test for, you should be able to hit the home button and navigate home, right? And so boom, boom, boom. So a lot of the same steps, just organized better. And so with this, we can see that in Playwright, this is how we can really start to scale our tests and break them apart. So I'll run the tests again. Boom. And now you can see they're running 4 times in parallel. Boom, they're all done. And if I show the report, you'll see that all of the tests were run successfully like that. Boom, boom, boom. And even I could run across different browsers now too. Oops. So let me Control C. So before I had limited it to only running on Chromium. If I remove that, by default, Playwright will run against Chromium and Firefox and WebKit all at the same time. And so here now we can see running 12 tests using 4 workers. And it takes a few seconds. Boom, boom, boom. Hopefully they all pass. If not, then we've successfully done Yep, there it goes. Cross-browser testing at its finest. All right. And so here we can see, here's this full spill out. There were 4 tests run against 3 browsers, all in parallel, for a total of 12, and even highlights which browser it ran on which. Yeah, so awesome. Everything is boom, boom, boom. That's right. So great. Okay. Okie dokie. Whew. So there's so much more I could show with Playwright. I could show the code generator where you can actually open up a browser window and step through the code, and the inspector will generate Playwright code for you. We could expand this test suite even further and just get like, files and files of test specs and make it go big. Um, but at the very least, what I have shown here should be a good starting point, right? Not only have you seen the basic mechanics of the commands, but you've also seen how to start to formulate a good project with good structure, how to move your interactions into page objects that are reusable, and how to create fixtures for those, and then how you can start to split apart your tests so you don't have these giant clumps. The final thing that I want to show today is how to use Playwright with Lambda test. Right now, so far, all of my testing has been done on my local machine. Right, I'm running a Mac. It's one of those it's like an M2 Mac. It's pretty sweet, right? Pretty fast. But ultimately, you don't want to be running your tests for credit on your local machine, right? The official runs, we can call them that, should be run um, in some sort of continuous testing environment, like a CI system or a pipeline, whatever you call them. Whenever developers make changes to your tests or make changes to the code, then tests should be triggering automatically, whether immediately after a code change happens or on some sort of routine schedule, hourly, twice a day, nightly, weekly, whatever, right? And those tests should be running on some shared system that everyone has access to, and the results should be posted publicly for everyone to see. Now, once you start to get into that kind of test execution, we realize that continuous integration is the production system for test automation. Let that sink in. Continuous integration is the production environment for test automation. Why? Because that's where they're running for credit, and that's where people are making business decisions about the development process based on the output of your test. Remember, we were saying before we're trying to build fast feedback loops. The fast feedback loop should be a production system for testing, right? And when it's lifted off of your machine onto that, then you start having to worry about things like scheduling, orchestration, resources available, right? And so and you might also need to be worried about cross-browser testing. Like, I need to be able to test this on these different environments. And so that's where, in addition to a CI system or a pipeline, a platform like Lambda Test can really help, because as you're running a load of tests, hopefully in parallel, hopefully at high scale, you need resources behind that for executing all those different browser sessions, right? Now there are many different platforms for running those browser sessions. Like an open source one would be Selenium Grid. You may have heard of other vendor names, but I'm going to be showing you how to use it with Lambda Test today. And everything I'm going to show you is documented on Lambda Test website, so you can download their example code and run with it as well. They also have examples for Playwright in Java and Python and C# as well as JavaScript. I'm going to be showing the JavaScript one, of course. So I have a bonus branch in my repo that has all this code. Okay, so how do we do this? So in order to run your Playwright tests using a platform like Lambda Test, you need to add extra configuration. It's a bit of code, it's a bit of boilerplate code, But like I said, you can basically copy paste it from Lambda Test website, because that's literally what I did. um, but the way that I recommend doing it is to add it as a fixture, right? You could smash it into an individual test case, but that's not ideal, because then you have to copy paste that everywhere, and it's a little sus. If you add it as a fixture, then it can override the existing page in browser fixtures, and then every test automatically gets it, which is really nice. So here under my fixtures directory, I've created a new module called lambda test.ts. And in here, I've set up all the code to configure Lambda test, which, like I said, I shamelessly copied and pasted from Lambda test website. So here we need to set up some capabilities. Things like, what browser do you want to run, what browser version, all this other stuff. We also need to configure our Lambda test username and our Lambda test access key. When you set up a Lambda test account, you'll get those things. Don't share your key. I'll share mine, but don't use it, because I can recycle it later. Right. As a recommended practice, you want to probably pass these in as environment variables, as is being done here. You could hard code it here. Don't do that. That's bad practice. Anyway, then there's ways you can modify your capabilities. Don't worry about that. But this is where ultimately the real connection comes in. You want to extend the base test from what's it called? From Playwright. And in here, we're going to override the page fixture. And here you can see we're adding extra code that will only do it if you're doing a Lambda test configuration. And then you set a special Lambda test endpoint with the capabilities that you put in. And then afterwards, you have to post the status of the test back to Lambda test, so it knows what went right and what went wrong. But once you do that, all of your tests are pretty much the same, right? So here, like, if you notice, like the demo to do app, the example tests, the Trello test that we wrote, I didn't change any of that code, and you shouldn't have to change any code whenever you use any of these all floating platforms. So if I were to run this, there is one other thing you need to configure. So inside your Playwright config test folder, or config test spec, where you have all of your project names configured, you will need to add special Lambda test project names. So I copied these shamelessly, but things like, hey, you want Chrome, latest Mac OS on Lambda test, or you want Windows on Lambda test. And you can set viewports and devices and all that kind of stuff. And so when you go to run it, we're short on time, so I'm just going to show you a previous run that I did. Here's the Lambda test dashboard. You can see all of your recent tests. And here you can see, if I go to the automation dashboard, you can see how I ran a Playwright TypeScript build. It's got my username on it. Hey, that's me, right? And then I can come into the dashboard and I can see all the tests I ran. So I ran one of the example tests. You can see, I ran the has title and the get started link test. And in here, you get the full spell out of the things that happened as that test was running. And this was running remotely in Lambda test rather than on my machine. So pretty cool stuff. You can see it passed. It's going to keep a full history of the things. And that is how you can run your Playwright tests with Lambda test. So, woo! I know we are very, very short on time. It looks like we have 5 minutes left in our session. Thank you all for sticking around to the end. I know it was a lot of information to cover. Normally, I give this as like a half-day workshop, sometimes a full-day workshop. So we had to kind of compress for 90 minutes. In the time we have left, Sparsh, good to see you back. Can we answer as many of the remaining questions as we've got?
Yes, definitely. First of all, Andrew, it was a wonderful workshop. I was able to follow each and every step. I was a very beginner in Playwright, but loved the presentation, loved the codes. I think you have almost answered a lot of questions. We'll just find some questions and pick up.
Sure. So yeah, let's refresh the votes. Let's see what we haven't answered yet. So I see Jane C is asking, what are the recommended approaches for managing authentication and sessions in Playwright? Excellent question. So with Playwright, you can, you can do old school style, which is like every single test logs into the app, which is great, but that's not very efficient. With the browser context, you can save the authentication cookie or the session storage or whatever. There on the Playwright documentation, I forget where, you look up like authentication or session storage, you'll see the patterns for it. And so what you can do is you can do it once and then just save it and refresh it for every single test. So that way you don't need to log in repeatedly every single time. Good question. Okay, what other ones haven't we answered? Let's see. We answered that one from Mike. We answered Mr. Braina's. We answered Vikash's about organizing. Okay, so Debbie Asho, what are the good framework approaches we can adopt in Playwright? I believe I've shown that here in the project, right? There's a difference between writing a bunch of Playwright scripts and building a robust, scalable Playwright project, right? You want to keep things organized. You want to have fixtures. You want to have page objects. You want to make sure that you're writing individual tests covering independent behaviors rather than combining them. You want to make sure that you're handling your test data so there aren't any collisions. Rajesh Balu, how do you make Playwright tests run faster than Selenium tests? They already do, my friend. You don't need to do anything. You need to install it and actually write the tests. And like I said, there are plenty of benchmarks and articles online where you can see exactly what execution time looks like. Paul, can you dig into how to test PWAs using Playwright and TypeScript? PWA. Paul, please drop in the chat and update the question for what the acronym is. I want to make sure I answer the question right.
I think Paul is talking about progressive web apps.
Progressive web apps. Oh, yeah. Oh, okay. Sorry. Okay, progressive web app. Yes. So what you can do with Playwright is that you can adjust the viewport size of your browser window. Like in the projects view in the configurations here. Playwright config test. You can see how we have all these projects named for different browsers. What you can do is you can see here, you can actually adjust the viewport sizes and choose different device sizes for these. And so that way you can test your application in different screen sizes to adjust for the different layouts for your progressive web apps. Good question. All right. Himanshu, which is better, Playwright or Cypress, and can they be integrated with AI? So I'm going to diplomatically say that all web browser testing tools are great and each one has their advantages and disadvantages. I have my preference for Playwright. I am a Playwright ambassador. I was the first Playwright ambassador. Ask me about that sometime. So I have bias, but I have used Cypress. I have used Selenium. In fact, I'm just finishing up a project using Selenium right now. Can they be integrated with AI? I guess. I mean, Copilot, right? Everything's going to be AI soon. Great. 2 more minutes. How many more can we answer? Neki, how to explore Gen AI in Playwright? What JS libraries are there to look into? Honestly, I don't know. I don't play that game. I know I've seen a couple vendors out there that are trying to do like calling assertions and behaviors from Playwright using AI back things. I think more likely what we're going to see AI used for in testing is not so much like embedded into Cypress or Playwright or something, but we're going to see test generator tools that are generating test cases using AI. I know Lambda Test has just released 𝐀𝐧𝐝 AI, which has a lot of those Gen AI features, which is really cool. So check that out. And then there's also going to be AI on the execution side of things for like analysis, triage, smart locators, better or worse. Yeah. All right. So Subin, what are some best practices for writing maintainable and scalable test scripts in Playwright using TypeScript? We've covered it. Things like page objects, fixtures, breaking apart behaviors. Paul again, how much of the web testing with Playwright and TypeScript can be automated versus manual? I mean, I would say pretty much anything you do on a website or a web app, you can automate. A Playwright can handle all the possible interactions, all the possible assertions, right? There's nothing on a web app that you can't test with Playwright. I mean, there might be certain facets of systems outside of your web app in your end-to-end processes that might be more difficult to automate. Things like, hey, I have a batch job that runs overnight that ingests like 10 gigabytes worth of data and it takes 2 hours to run. Maybe that's something you don't want to automate. Or things like, hey, I have to create new user accounts, and then that requires, email verification, right? Maybe that's not something you want to automate, right? But anything that's happening on the web page, you can do with Playwright. All right. I want to take one more question because we are at time. Prachi, what are some best practices for structuring Playwright tests and TypeScript? Again, we've seen it in the examples. Cool. Alrighty. So I believe that is all the time we have.
Thank you so much, Andrew, for the wonderful workshop.
I'm tired. I need lunch.
I've also dropped Andrew's LinkedIn down in the in-session CTA. Please do follow Andrew. He keeps sharing a lot of tips and tricks to do automation in Playwright. And thank you all for being such a lovely audience, making the chat interactive, putting up your questions. For those who want to revisit any part of this workshop, remember all these sessions in TestMu will be available on Lambda Test YouTube channel, so that you can dive back into today's content whenever you like. Thanks again for joining, and thank you, Andrew, for being.
Thank you, everyone. Yes, keep in touch. Follow me at Automation Panda. You know how to